talk a little bit about the underlying technology of testing a web application, and that means testing a web application on a mobile device. We'll talk about how our solution, eValid, supports mobile device testing. I'm going to briefly touch on how to create an Ajax application, and in that I'll mention a little bit about how to pick out key performance indicators, KPIs, and how eValid can grab the KPIs in real time, including when it's running on a mobile device. And then finally, I've got a couple examples of where we run load tests, and from the results of running the load tests, we can draw some inferences about the problems and issues of what's going on in the server stack. Now, excuse me, the main thing to recognize is that we are, and if this is not your subject area of interest, I mean, you're welcome to listen in, but I don't want to have anyone be deceived. We are not testing mobile devices. There are really good solutions for testing a mobile device. There are emulators. I recently heard of a company that actually sells time on a hardware-based multiple smartphone simulator, which you know, you can actually go and try your manual tests out on several hundred different mobile devices. But we're not testing devices. What we're testing is the interaction. And if you look at this flow diagram here's conventional TCP/IP applications where you sit here on the desktop and you go through your ISP and it goes through the web and it talks to a server. We view in this particular webinar that a mobile application has the same physical structure. You're sitting on a device, which is a browser, some device, and the application is being served by a server, and to communicate that we're not testing apps, we're testing web apps. So in a web app, you go from a mobile device over the web, or you go from a laptop over. In our view, what's important is the interaction between the client and the server. And what eValid brings to the table, because eValid is a test enabler, because eValid is a browser, the perspective of the testing is from the point of view of a user, and the perspective of making a measure. Failure modes for web browser-enabled applications, they almost always are based on failure of content or failure of performance. And performance is the one that gets the most applications these days have basic performance pretty well understood. You very rarely see a functional failure. I wouldn't say very rarely, but most of the simple functional failures are long ago taken care of by internal testing, manual testing, and so forth. The same is true on a web browser, on a mobile device, but the real issue, and I'll get to this when I talk about this example down here, the real issue with the mobile device is how long does something take to show up on the mobile device? Okay, so there are a lot of different kinds of mobile devices, and all of these seem to be included in our solution. And we listed here everything from mobile phones to desktops to Macs to whatever. How do we make a browser, our browser, appear to a server? Remember, we're looking at this diagram, so we're talking about, we're sitting over here on a mobile device or a laptop. We want to make the server think that it's talking to a mobile device. Well, that turns out to be pretty easy. There's a thing called the user agent string, and I just went to the website useragentstring.com, and it told me that I'm running IE version 7 on this computer. So if now a little bit of a piece of technology. Here is the eValid product, and I just want to do a couple of things here. Oops. You'll have to forgive that bong. I can't get rid of that. Anyway, there's the eValid product, and it is a browser. Now, people criticize us for not having a tabbed browser, but in the case of an application that opens things in sub-windows, eValid handles those as sub-windows. eValid is a regular browser, and it has performance measurement, record play, site analysis, a wide variety of functions built into it, and that's fairly important. And the one command that eValid has that you use a lot is the command called set user agent string. It is recorded from the eValid browser. It's a command that you do have to edit in, and there are techniques for editing commands in after the script is created. Tell eValid to behave as if it was some other browser. Now I've got a couple of these set up, for example, if I want to use a batch command, this is an important file. If I just look at this material right here, that passage, that's a batch command that sets eValid up to look like it's a WebKit. Oh, that's an iPad, and here's the one for an iPhone. And I'll just bring up the one for an iPhone. I happen to have it sitting right over here. So let's bring up eValid as an iPhone. And if I go off to something on eValid as an iPhone like this, Amazon.com, I get a display that looks like this. If I go to the regular eValid browser, which is this one, www. You get a much different picture. For example, this picture has all of this stuff on it, all right, but you don't get that on the mobile version, all right. So the difference, I want to emphasize the difference between this picture and, this picture here and the one on the right. The one on the left and the one on the right is that this one is pretending, eValid is pretending to be IE, which it naturally is, and this one is pretending to be an iPhone. Now, how does eValid know to be an IE browser? And that is the following. Desktop application that runs on the COM on this desktop, and this is the way you would launch it, just like this. It'll come up in a second. Our product grabs the libraries, IE library. So that's how eValid gets to be an IE browser, and then we make it pretend to be something else. Now, so that's how you would bring it up with a specific user agent string, and we've done a number of experiments here that I want to show you. I don't want to overload you with too much information, but then again, I want to overload you with a lot of information. Here's eValid dressed up as a iPhone viewing, looks like 6 different websites. And in this case, we ran the application, and one of the things eValid does is when these were done by a little script that we wrote to show what these things look like, and there's even a script that automatically saves the screen image. These are all capabilities within the eValid browser. Go back here so you don't look at Amazon and try to buy something from Amazon while you're watching a webinar. In this case, you see the vast difference between what the server delivers to the user, the client, if the client is an IE browser versus an iPhone. And we also calculated out the difference in size. The iPhone is 5% of the volume. Mibu, whatever that is 18%. Samsung's homepage, Samsung, of course, and Apple have been in the news a lot. And so that's a 12%. Some websites, like the Sony website, when the user agent string is an iPhone. And so here it's 88%, and in the case of Verizon, it's 93%. I guess it's that's supposed to be a joke. Anyway, so you basically dress eValid up as to imitate. So here are 5, here's one, and here's the other direction of that chart. Here is the same page delivered on 5 different phones, again with the byte count included, and a Samsung Galaxy, that's an older one, IE, whatever that is, and Sony Ericsson and so forth. The trick is, now remember, we're dealing with a web application, a web browser-enabled application. So what's really important is how does the eValid engine, disguised as a mobile device, how does it interact with the server? So I've got one more thing here to show you the another example we did, selected screenshots, that comes up on your screen, and you can see that eValid causes the server, as examples, and just so you know that we can do this for a lot of different examples. Here's the wrong picture. Here's one with 203 different, it comes up on your screen there. This particular page has 203 variations. So we did this, and this is an interesting possibility for you. If we want to verify that a web application behaves correctly on a target device, all we do is load eValid up, have it imitate, set the user agent string to be something other than IE or Chrome or Firefox or Safari, and then we can do screenshot comparisons of the rendering achieved by the browser. So what we're really testing is two things: the content, what's delivered over the wire to the browser face, and the performance of how long that stuff takes. Okay? So we did some side-by-side sample screens. Here's a good example. We did device 1, device 2, tablet, and so forth, and we chose all these varieties. And then when I get the screenshots from this, you see the same kind of variation. In this case, we did a playback of a multi-step playback, and we saved 3 screen images for each one of those. We're comparing Samsung Galaxy S2 versus Tab 10.1, something or other, and with different screen resolutions. So we can perform that variation too. So if you're looking at the content analysis by the device, you can achieve the content checking mechanically. Now, I mentioned also that performance was the other factor. And if you think about it, how fast something downloads to a particular device is what's important. In this particular 3 devices that you just saw, that's where is it? I lost here's my 203 devices. We did the chart of the download something. That is, some of the download times. This is basically looking at the total volume of material and kind of categorizing it. The webs, so what they deliver to the client browser is a smaller volume of material, of course, perform quicker. Now, you might look just measuring how fast the web runs. Well, it is indeed a measure of how fast the web runs, but it's also a measure of how quickly the device, and how quickly the device responds as it's delivered. And you see there is quite a bit of variation from anywhere less than, see, this is a download kilobytes, and this is number of seconds, 1 second to 2 seconds. So the smaller, 2 seconds is up there about the 3-second threshold. 3 seconds is when people are known to disappear in terms of, hey, I didn't wait, it didn't show up on my screen, so I'm moving on to something else. Those websites that deliver to an eValid instance that's doing the measurement, that deliver too many bytes, are going to be way outside or close to the limit on capacity. All right, so the main points so far: we can have eValid pretend it's some other browser. And number 2, we can have eValid measure byte count, which is size of what's downloaded, and time of how long the download took. Okay, so that's device support. Now, the next part of the talk is to deal with the question of AJAX, asynchronous JavaScript and XML. We all know that what are called declarative websites that simply navigate from here to here to there. And this page right here is a typical declarative website. This is simply it's a page on our website, and it has a series of links, but there's no significant user interaction here. But these days, if you're using a web browser in the same way Rita was describing at the beginning of the talk, then you typically need to have an AJAX capability. Now, I'm not going to go into in this webinar a very great detail about how to succeed in creating a functional test, but I will show you a couple of the key factors. And then I have a demonstration of Salesforce, Salesforce test, which we're going to play back. The key factor is that when eValid is making a recording, and I'm going to not make any recordings, but I'm going to point out that eValid has a capability of, during recording, to validate, this is called validate and synchronize on a piece of text. And what that means is that I can use eValid to create a very reliable AJAX recording out of the GUI. Now, I'm familiar with all the other products you might be looking at, including those that are the supposedly free products that cost 4 times as much in labor costs because they're free. I'm familiar with all those technologies, and I believe that what we offer is a pretty good solution to the problem of how to get synchronization. Let me emphasize it this way. If you're doing a test, and eValid can record a playback in real time. We record the wait times like everyone. But if you rely on the wait times for synchronization, there'll always be an instance where the wait time is too slow. So what we've done is we've created a recording, we've outlined here, a recording protocol which, using eValid, will generally produce a reliable AJAX test playback. And that process is simply to use the browser to go someplace. For example, go home. Well, go on GUI tour. All right. And if I'm on the GUI tour and I want to make sure I'm okay, then I take an action. You see, I take a required action, and then I do record, validate, and synchronize like that. Generally, if you're highlighting an AJAX application, you would go to the very last part of the page. So you would do something like any differences found to be the validate and synchronize text string. What happens is eValid puts a sync on text command into the playback. At playback time, eValid will wait until the current page shows the particular, the script that we're going to do here is, this is the script that tests Salesforce, and this script was recorded from life, and then it was augmented. But you see in Recording for Life, we go to Salesforce, and there's the sync on text. So we wait. The way this passage works right there is the playback engine, as a functional testing engine, it'll either wait the 9.3 seconds, that's 9,307 milliseconds. It'll either wait that long, or if I have the wait time set to some maximum ceiling, that it will then not continue the playback until the word password shows up on the screen. We call such a script AJAX, an AJAX script that's fully self-synchronized. All right. Now, I mentioned the playback settings, and I want to show you the GUI a little bit. Record play preferences. Wait till that shows up on your screen. All right, I'll get it over here so you can see it. The record play preferences are probably right back here that I want, or in playback. And so, for example, I have my browser set to have a wait time ceiling of 1 second. Okay, I could also have a wait floor, and there's also such things as a command delay. In this case, I've got a 1/4 second command delay. It says wait a 1/4 second and then do the synchronization, and then do waits, and then do the synchronization. So with that setting, I should be able to have a good, reliable playback. Now, there's another aspect of this particular script. Is when you're dealing with eValid, you're dealing with eValid's command language. And people have criticized us for calling it a language because, in a way, it's really a JavaScript. It's really more in the sense of a command language that you run a series of commands. So, for example, sync on text page that you have has got a thing called username. You drop a text into, actually, you drop a text into this document object model index number. Sometimes you want to have the playback be a little bit more sophisticated. So all of this recording is done with sync on text, but yeah, this one's all done without any structural testing commands. But we do have commands that will allow you to do synchronization on the content of any document element. So it's can be very sophisticated. What's called structural testing with eValid can actually yield a test that plays back even if the page changes in terms of content, as long as it doesn't change in structure. Something has to be constant. Now, let's just play back this. Let's see what happens. This is the nightmare that you always have if you're giving this kind of a webinar, is that you play this back, and here is the actual script. And we got the playback to occur in just 32 seconds in that version. Okay. Well, I'll just move forward here. So, suffice performance indicator in this JavaScript, in this playback, let me find the right example. The key performance indicator is how long does it take to do a particular thing, the mobile device loading. And the mobile device loading, I'll come back to this. The script here. Now here is another script, and again, I don't want to show you scripts and ask you to understand them in real time. I just want to illustrate that the key performance in this particular example was the amount of time that it takes. Now this application is run for it's a mobile app that runs on an iPhone, and we use structural commands or index motion commands to measure time. And here's the elapsed time till we get a schedule data. All right. So here is the key performance indicator, the KPI, right there. And so in the KPI, which your link on this website, the name has been protected here because we don't reveal who that is. We wait till departure as of, and we sync on 3 different things. Notice we're waiting for minutes and car, and then we do a click on time schedule, and then there's a special command in eValid called save record. What save record does is write a timing data. Okay, so we did 2 experiments that I think are interesting. The first one is this simple loading experiment, and in this case we had one script. Let me put the application up so you see what it is. We had one script that goes to an application, we're pretending we're an iPhone. See, we're pretending to be an iPhone, imitating an iPhone, and then what we do is we ramp the load up to 100 browsers. Well, how do we ramp the load in eValid up to 100 browsers? And the answer to that is we use a feature in eValid called the load test, open load test, load test, new load test. We use a thing called the load test editor, and the load test editor will let us do all these kinds of fancy things. And we basically construct an EVL, and we phase the EVL, that's the eValid load test playback, so that we get 100, in this case for one user, we get 100 browsers running, and then we measure the time, and this one also has, see, it has a reset timer and a save record, elapsed time. And so we look at that, and now with going up to 100 users. And you see a pattern here. The pattern is that the response time of the, now it gets closer, web server constellation as appearing to the user is pretty good at response times of probably 75 users. Then you start to see this queuing capability. This business here with these 75 plus playbacks is all waiting for something to happen. The server is saturated. So I can infer by collecting this data something about what's wrong with the server. So there we are with 100. And in this particular case, 100 browser users on one machine. I know that others offer, people claim you have to have 10,000 users, but I don't see why you need 10,000 users if you can demonstrate degradation of performance. The difference is, of course, that you are using a much more realistic simulation, and you're collecting much more detailed data. That's how you can get the data without it being a very complicated situation. The second experiment is this one, which is the chart at the top. I'll get to that in a second. The second simulation, we're looking like, again, an iPhone. I don't know why. Why are we picking on iPhone? Looking at an individual departure time. And in this case, we ran the browsers using 100 browsers per user on a to get the capacity of the biggest Amazon 6-core, 65 gigabyte machines, and we collected the saved data records, the saved record data in a central location on that machine. We used 10 users going on here. Here is the chart of the rate at which we load to 1,000 browsers. So at this point in time, from I guess 12 noon to 12:15, time. And then when they got the data, the playback would start all over again. There's a feature in the load test that says, don't just run it once, run it continuously. The question is this. Can you look at this chart? I hope you can. Okay. Can you look at this chart and see where the performance begins? Performance is pretty good at less than 10 or 20 seconds. But when you get to about 200 browsers, then somewhere around 200 browsers, the number of browsers running in parallel. And it's pretty clear then that you have a server outbound capacity problem. In this particular case, again, I don't want to reveal the customer, but what we said to the customer is, it looks like you've got about a 5 megabit per second outbound server for your application. The guy said, how did you know that? I said, well, we calculated about 200 times the data volume, and we figured out what that was. It looked like it was about 4.8 megabits, so we made a conclusion. You've got an outbound upload from your server of about 5 megabits per second. And he said, "You guys are too smart for us." Anyway, that was a very interesting experiment that we've used a lot because it really tells exactly how simple this can be. Now, I just want to show you the one more screenshot. To get this to all happen, what we did was I wanted to illustrate we really do run 100 browsers on one user, and here's an example of doing that. There's another example which we don't have an animation of, but there's one that's very nice that brings up 100 browsers, and they all run once and disappear, and you watch the 100 instances all twinkle out. A detail that's worth mentioning is that this is the smallest browser you can get. So when you tile eValid, this is the smallest you can make that. And but this picture does show the same kind of thing that we were showing a moment ago. Now, so I've talked about that. Drawing conclusions, we can look at the curves. A couple of important caveats in doing this kind of server loading work. I'll put the chart back up. You generally want to watch out for the implications of what happens when there is a load balancer present. We had one experiment that we did for a customer, and the performance starts to degrade, then all of a sudden, wham, the performance got better. It was degrading, and wham, it got better. We said, what's going on? The answer is the web load balancing software came into play. And this becomes important for web browser-enabled mobile apps because most mobile apps are being run from cloud resources, which are basically rubbery. The more resources you ask for, the more you need. But the real issue is how many browser users can you run on one server. So my injunction here is make sure that you have the load balancing systems turned off and the auto resource allocation system turned off. Now, finally, and I'm coming up to my 35 minutes or so, finally I want to point out one thing. This particular experiment, all right, I said at the beginning that I thought that most people believe that testing a web browser and application is hard. I would say that today you can run this kind of an experiment on some one type of device in, all told, from start to finish, even learning how eValid operates, following the examples we have on our website and in the web forum, you could run that experiment in less than a week. One person in less than a week, say 4 days. If you increase the number of devices to see how the dependence of the web application is a function of devices, then you could get probably the second experiment in 1 more day. So we're not talking about spending a lot of time for people to come up to speed in programming Selenium or WebDriver. In other words, learning how to program web tests in JavaScript. We're not talking about how to solve the problem of running your tests in what they call the grid, which is one separate machine for each playback session. What we do is we run up to 1,000 playbacks in a single machine. We do that, by the way, because there's a feature we have in eValid called the thin feature. I'll take that away. I don't know why that's on there. Remote desktop connection. The eValid thin browser has the smallest footprint and it's the least. It has the least adornment, but it's a full-scale browser. It has all the features of eValid in playback mode. So the important thing to emphasize is that testing a web browser-enabled application is not only not hard, it's really very simple, and we think that this is a solution that people should look into to consider when you're taking on a project. Most of the technical difficulties inside the way eValid is architected. And let's just review that. One, it's a browser, so you have absolutely any kind of device. If you want to be a PC or tablet or any other device, handheld, smartphone, whatever. And thirdly, we can extract KPIs. I showed you timing, but you can also grab byte counts. That data is available from the save record command. And you can extract KPIs from a single session, and you can leverage a single 50, 100 on a single user up to 1,000 on a beefy machine, and you can do this all very, very quickly and very economically. Now, I know you could spend a lot more money and a lot more effort to find this solution all that credible, and they go off and they spend hundreds of thousands of dollars, but we're talking here spending just less than a man week and license fees are not that exorbitant.